Hi students, in previous class we have discussed greatest integer function f of x equal to step x, which is continuous at non-integer, which is discontinuous at integer. Okay, step x is continuous. Step x is continuous at non-integer. Step x is discontinuous at integer. This is the most important question, 4-mark question. This is yesterday we have discussed this one. Okay, today let us discuss about algebra functions. Algebra of continuous functions. Algebra of continuous function. Algebra of continuous functions. Let f and g are real functions. F and g are real valued functions. And continuous every way. Okay, f and g are real valued functions and continuous every way. Okay, is continuous, for example, at x equal to a. Okay, then f plus g is also continuous. F plus g is also continuous. F and g continuous, then f plus g also continuous. This is the first property. Are you following? F and g are continuous function, then f plus g is also continuous. Okay, how? Let limit x tends to a f of f plus g of x equal to limit of x tends to a. Tell me here, f of x plus g of x. Put x equal to a, limit of x tends to a, f of x plus limit of x tends to a, g of x. Put x equal to a, f of a plus g of a. F of a plus g of a. This we can write f plus g of a. This is limit value and this is limit value and this is function value. Therefore f plus g is continuous. F plus g is continuous. Okay, first step, if f and g are continuous, then f plus g also continuous. This is the first point. Similarly, second point, f minus g is also continuous. Proof not necessary. The statement important. If f and g are continuous, then f plus g is also continuous, and f minus g also continuous at that point. Okay, f into g is also continuous. F into g is also continuous. And fourth one, f by g, where g not equal to 0, is also continuous. Okay, f by g, where g not equal to 0, also continuous. This statement, this property is very important. If f and g are continuous, there are two functions. The combination f plus g is also continuous, f minus g also continuous, f into g also continuous, f by g also continuous. Example, f of x equals x and g of x equal to mod x. F plus g, add both, you will get x plus mod x. X plus mod x. X plus mod x. Tell me, x is continuous or not? X is continuous or not? Yes. Which is polynomial. Mod x is continuous or not? Yes. Mod x graph, how is it? V shape, there is no break in the graph. So mod x is continuous. X is polynomial continuous. Mod x is also continuous. Then f plus g is also continuous. Means x is continuous, mod x is continuous, then x plus mod x is also continuous. X minus mod x also continuous. X into mod x also continuous. But x by mod x not. But x not equal to 0. If you take x equal to 0, it became a infinite form. The denominator is 0. Here, f by g is continuous when g not equal to 0. This is called rational function. Rational function is also continuous. Because f and g both are continuous, then f by g where g not equal to 0 is continuous. So here x not equal to 0, except that in many cases it is continuous. Understood? Okay. The most important point here, f and g are continuous, then f plus g continuous, f minus g continuous, f into g continuous, f by g is also continuous where g not equal to 0. Okay. Next, sin x. Show that sin x is continuous everywhere. Question. Show that sin x is continuous everywhere. Sin x is continuous everywhere. How we can do that? Let f of x equal to sin x. F of x equal to sin x. Take any point, let x is equal to a, where a belongs to real numbers. Any point. It may take 0, 1, 2, 3, anyone you can take. X equally belongs to 1. Tell me f of a equal to sin a. Next, limit value x tends to a, f of x equal to f of a. F of x, limit of x tends to a, f of x is sin x. Sin x. Put x is equal to a, sin b. So limit value equal to function value. Therefore, limit of x tends to a, f of x equal to f of a. Therefore, f is continuous. F is continuous at x equal to a. So sin x is continuous. Sin x is continuous at x equal to a, where a belongs to r. So sin x is continuous everywhere. Sin x is continuous. This we can do by graph method also. By graph method. Graph method. See, sin x graph. I think you know how is the sin x graph? Wave shape. Like this. Like this. Is there any break here? Is there any break in the graph? No. There is no break in the graph. So there is no break. Here it continues. If you take value, you get like this. It goes up to minus infinite, plus infinite. Okay? There is no break here. So there is no break. There is no break in the sin x graph. Therefore, sin x is continuous. Sin x is continuous every way. Okay. Similarly, what about cos x? Also continuous because there is no break. Are you following? So sin x is continuous, cos x is continuous. 2 points. Okay, sin x is continuous. And second point, cos x is also continuous because there is no break in the graph of cos x. Third one is tan x. Tan x. See, f of x equal to tan x. F of x equal to tan x means sin x by cos x. Sin x by cos x. See, just now we have discussed, this is f of x, and this is g of x. F is continuous, sin x is continuous, cos x is also continuous, f by g continuous, where cos x not equal to 0. This is cos x not equal to 0 is continuous. At what point cos x is not equal to 0? At what point? If you take x is equal to 90, x equal 90, cos 90, 0. X equal 3 pi by 2, 0. 5 pi by 2, 0. So on. So, f of x equal to sin x by cos x tan x is continuous. Continuous. Tell me, at what point? At all real number except 2n plus 1 into pi by 2, except these points. What is the general form of this is 2n plus 1 pi by 2. So cos tan x graph has a break at what point? 90, 3 pi by 2, 5 pi by 2, 7 pi by 2, so on. So at those points graph has a break, therefore the tan x is discontinuous at that point. Okay, so tan x is continuous at r except 2n plus 1 into pi by 2. Tan x is discontinuous. Tan x is discontinuous at what point? Discontinuous at, tell me, x is equal to 2n plus 1 into pi by 2. X is equal to 2n plus 1 into pi by 2. This is general form. We can write like this. Set off, so on, minus pi by 2, plus pi by 2, 3 pi by 2, 5 pi by 2, so on. What is general form of this? X is equal to 2n plus 1 into pi by 2. Right? If you draw the graph, the tan x graph, I think you know, 0, here tan 90 here, 3 pi by 2, then minus pi by 2 here. Tan 90 infinite, the graph. Here not intersecting. Next, we get like this. Here break, 3 pi by 2. This is pi, here 3 pi by 2. So the graph has a break at what point? Pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, so on. Therefore, tan x discontinuous at what point? Pi by 2, 3 pi by 2, 5 pi by 2. What is the general form of that? 2n plus 1 into pi by 2. So the tan x continuous r except 2n plus 1 into pi by 2. Sin x continuous every way. Cos x continuous every way. Tan x continuous at all real number except 2n plus 1 into pi by 2. Okay? Understood? Why except these points? Why these points discontinuous? At this point the graph has break. What about cot x? Here tan x is continuous. Continuous at all real number except 2n plus 1 into pi by 2. Right? Next, the fourth one, f of x is equal to cot x. Tell me, cot x graph you see, where it has a break. Cot x graph. Cot 0, infinite. Cot pi, infinite. Cot 2 pi, infinite. So the graph, the cot x graph, at what point the graph has a break? 0, pi, 2 pi, 3 pi, so on. Okay? Cot x graph 0 is a pi, it's a 2 pi, cot 0 is infinite, cot pi is infinite. This is okay, cot pi by 4 is 1. Like this. Like this. Here break will be there. So the graph has the cot x graph. Cot x has a break. graph has a break. Cortex graph has break. At what point? At what point x is equal to, tell me, minus pi, 0, pi, so on. So what is the general form of this is x is equal to n pi. For all n belongs to z. Okay. Therefore cortex is continuous at what point? Cortex is continuous at all real number except n pi. What about sec x? F of x is equal to sec x. Sec x at what point has a break? At what point will get infinite? Sec 90. Cos 90 0. Sec 90 infinite. Sec 3 pi by 2 infinite. Sec 5 pi by 2 infinite. Tell me at what point the graph has a break? Sec x graph has break. At what point? Tell me. So on, minus pi by 2, 0, pi by 2, 3 pi by 2, so on. So what is the general form of this is? 2n plus 1 into pi by 2. Therefore, sec x is continuous, tell me, at all real number except 2n plus 1 into pi by 2. Okay. Similarly, sixth point is cosec x. F of x is equal, cosec x is continuous, tell me, continuous at or except n pi. This is. There are 6 points. The most important, sin x is continuous everywhere, cos x is continuous everywhere, okay, tan x is continuous at all real number except 2n plus 1 into pi by 2. So tan x is discontinuous at what points? These. Tell me those points. Pi by 2, 3 pi by 2, 5 pi by 2, so on. Okay. Cot x is discontinuous at what point? 0, pi, 2 pi, 3 pi, 4 pi. The general form is n pi. Therefore continuous at all real number except n pi. Next. Sec x is continuous at all real number except 2n plus 1 into pi by 2. Cosec x is continuous at all real number except n pi. Okay. Understood? Mod x is continuous or not? Mod x is continuous or not? Yes, because there is no break. The mod x graph is like this. No break. Step x is continuous or not? Continuous at what point? Non-integer. At non-integer, no break. Non-integer, no break. At integer, break. At integer, break. So step x is continuous at what point? At non-integer. Discontinuous at integer. Okay. It was asked last year CET question. F of x equal to step x is continuous at CET 2017 question. F of x equal to step x is continuous at option 5, 3, third option is 3.1, fourth option is 6. Which option is right? Third option. Why? Because it is a non-integer. It is continuous at non-integer and discontinuous at integer. Basically. Sin x is continuous, cos x is continuous, tan x is continuous or except 2n plus 1 pi by 2, cot x is continuous or except n pi, cosec x is continuous or except n pi, sec x is continuous or except 2n plus 1 into pi. This point is most important. Okay. Now, one question I am giving here, CET question. F of x is equal to cot x is discontinuous at x equals at x equals 0, 1, pi by 4, 3 pi by 4, which is correct? 0, because part 0 is infinite, discontinuous. Okay. Now the question number, yesterday we have discussed some fake questions. I think up to 19th over. Was? Okay, 19th. Question number 20. Is the function f of x equal x squared minus sin x plus 5 continuous at x equal to pi? Continuous at x equal to pi. Continuous at x equal to pi. This is f of x. Okay. See, this is x squared plus 5 polynomial. Sin x is also not polynomial, but it is continuous. Therefore, f plus g also continuous. Alright, at what point we are going to find? At x equal to pi. Find the function value, put x equal to pi, f of pi. Put x is equal to pi square minus sin pi plus 5. Pi square, sin pi value 0 plus 5. Right, limit x tends to pi f of x equal limit x tends to pi f of x equal x square minus sin x plus 5. Put x equal to pi here, pi square minus sin pi plus 5. Pi square, sin pi is 0 plus 5, which is equal pi square plus 5. Both same or not? Yes. Therefore, f of x is continuous. F of x is continuous at x is equal to pi. This we can say simple. X square plus 5 is polynomial. Sin x is polynomial. If f is continuous, then g is continuous, then f minus g also continuous. X square plus 5 is continuous because polynomial. Sin x is also continuous. Both are subtract here, x square plus 5 minus sin x is also continuous. F minus g is also continuous. Like this also we can do it. Okay. Next. Question number 21. Discuss the continuity of the following functions. A. F of x equal to sin x plus cos x. How to discuss this? There are two functions, sin x and cos x. So sin x, just now we have discussed, sin x is continuous. Sin x is continuous everywhere. Sin x is continuous everywhere. What about cos x? Cos x is also continuous everywhere. So by definition, if f is continuous, if f and g are continuous, then f plus g is also continuous. If f and g are continuous, then f plus g also continuous. This is f, that this is f, this is g. Then sin x plus cos x also continuous. Therefore, sin x plus cos x is continuous. In that second question is sin x minus cos x is there. So sin x minus cos x also continuous. How? Property. If f and g are continuous, then f minus g also continuous. Third question, sin x into cos x. Say, if f and g are continuous, then f into g also continuous. Sin x into cos x. A, B, C. The question number B, f of x equal to sin x minus cos x. Question number C, f of x equal to sin x into cos x. This This is by second property, this is third property. So 22 already we have discussed the continuity of cosine. Cos is continuous everywhere, and cosec x continuous at r except n pi. Sec x continuous at r except 2n plus 1 into pi by 2. Cot x continuous r except n pi. Find all points of question number 23rd discontinuity of f of x is equal to sin x by x if x less than 0, x plus 1 if x is greater than or equal to 0. See, the function is changing at what point? 0. So it's changing at what point? X equal to 0. Let's find left limit LHL, limit of x tends to 0 minus f of x. Limit of x tends to below 0 sin x by x. As standard formula, limit x tends to 0 sin x by x equal to 1. RHL. So limit of x tends to 0 plus f of x. Limit of x tends to above 0 x plus 1. Put x equal to 0, 0 plus 1 equal to 1. Left limit equal to right limit. What is the function value? F of 0. F of 0 comes under this. Put x equal to 0.